All right, welcome. Today we're going to talk about 11.6, which is directional derivatives and the gradient vector. Okay. Kind of already covered some of this stuff, but just good to see it officially. Okay, so let's say we have some function. Let's say we have f of x, y, z be a function. Okay, and we're really, I'm going to use a little bit of notation here. I'm going to use this notation. It's from R3 into R. Okay, so this is space. That means it's a function of x, y, and z. And R means our output is just a number. Okay, a real number. Okay, so then the gradient some people put a little arrow over it, of f is equal to, and it's a vector given by the partial of f with respect to x, partial of f with respect to y, partial of f with respect to z. Okay? And then when we do this, we're going to take what's called a directional derivative. So let's let u be a unit vector. That's the norm of u equals 1. Then some people write, I think it's written in the book, du of f equals the gradient of f dotted with u, okay, which is going to be, of course, partial of f with respect to x times the x coordinate of u plus partial of f with respect to y, the y coordinate of u, partial of f with respect to z, the z coordinate of u. Okay, so that's the directional derivative. Okay, so let's do an example. Let's let f of x, y, z equals x e to the y plus y e to the z plus z e to the x. Okay, and we're going to find the directional derivative okay, at 0, 0, 0 in the direction v equals, I should say in the direction of v equals 5, 1, negative 2. Okay, so now the first thing, this is not a unit vector. So let's go ahead and write the unit vector. So our u will be that same 5, 5, 1, negative 2, but now divided by the square root of 30. Okay? So now we're going to take the gradient of f equals partial of this f with respect to x is going to be what? E to the y plus z e to the x. That's the derivative with respect to x here. Derivative with respect to y is what? E to the z, nope, that x e to the y plus e to the z. And derivative with respect to z is going to be oh, sorry, y e to the z plus e to the x. Okay, we're going to put in 0, 0, 0. Okay, that's the point we put in. So if we put that in, we're going to get 1, 1, 1. Okay, so our directional derivative is going to be 1, 1, 1 dotted with 5, 1, negative 2, remember divided by square root of 30. It's going to be 1 over root 30 times what? 5 plus 1 minus 2. That's going to be 5, 6, 4 over root 30. Okay, and is there any way to, nope, no simplification. You could rationalize it, but that's not it. Okay, all right, I'll see you in the next video.